Hello, folks. My name is Tejas. I am Principal Program Manager for SQL Server Product Group. I own SQL Server on Linux and Linux containers, the cross-platform experience for the server side. And I have here with me Louis Immerschein. He is a Principal Product Manager for Red Hat for SQL Server workloads. So yes, that's a thing now. Microsoft having Linux expertise and Red Hat having SQL expertise. It's a thing now. So, let's get started. Just a request: please, silence your phone. It can be a little distracting for everybody else. So I would appreciate if you do this. So. Before we start talking about SQL Server 2019 and what's new for SQL Server 2019 on Linux and Linux containers, let's take a step back. Let's take a look back to understand where everything came from. So the whole journey started about 5 years back, and we had some very smart people like Slava and George and a bunch of other folks who basically said, why can't we run SQL Server on Linux? And apparently, everybody had different ideas of why it can't be done. So they said, you know what, we'll do it. And from there, they talked with our MSR program, which had a project called Drawbridge to run Windows programs in Linux ecosystem. And from there, our team created something called SQL PAL, or what we call Platform Abstraction Layer. It allows us to run Windows binary in SQL Server with extremely thin layer of wrapper. That's it. And our SQL Server from on Windows, we actually brought it as is to SQL Server on Linux. We didn't recompile everything. We didn't have to relink everything to new standards. It's just SQL Server on Windows running on Linux. So that allowed us to bring SQL Server on Linux with SQL Server 2017 a couple of years ago. And not only that, it allowed us to bring it quickly and iterate over it fast, because whatever we are doing for SQL Server on Windows is directly relevant to SQL Server on Linux, because it is just SQL Server. So what is it? What is SQL Server on Linux? So SQL Server on Linux is now available today obviously on Windows ecosystem. It's there. It's going to be there forever. Let's put it that way. So yes, SQL Server on Windows does exist. But we also brought SQL Server on Linux, especially the Red Hat ecosystem, SUSE ecosystem, and Canonical ecosystem with Ubuntu. Not only that, we also made SQL Server available in Linux container format, so it can be run in Kubernetes, Docker runtime obviously, but in Kubernetes and in an OpenShift environment, which are like amazing orchestration engine for containers for enterprise environment. And when we brought it over there, the one thing what we did was we also learned about Linux ecosystem, and we decided we don't want to bring the SQL installation experience from Windows to Linux. Let's go native when it comes to the configuration, installation, and everything around that. But let's keep SQL Server as is. So we now when you are installing SQL Server on Linux, you can simply do yum install or apt install, and we have the Linux native packages available for you to use SQL Server on Linux. Not only that, the key part, because SQL Server in Linux is essentially the same binary as SQL Server on Windows running in SQL PAL, the database compatibility is exactly the same. You can take a backup of SQL Server on Windows, restore it on Linux, then back it up from Linux OS, restore it on a container, and bring it back to Windows, and everything just works. Everything is just compatible, because it is, after all, the same thing. So as we brought this, and it's been a couple of years, so I just wanted to talk about what did we learn, and how did we decide to make progress from there. First of all, the first question a lot of people ask us is anybody using it? I wish I could tell you the real telemetry and the real numbers, but yes, lots and lots of people are using it. These are just some of the numbers that some of the names that we got permission from them to talk about, but we have lots more customers using SQL Server on Linux and Linux containers today. By the way, the 11 million Docker pools, that's like a 6-month-old number. Last I checked, it was way north of like 20 million Docker pools. So yes, it is being used and used very frequently. What else? What did we learn about the customers, their adoption pattern? Why are people looking at SQL Server on Linux? And we learned something. One thing what we learned is the world is not made out of entirely Windows. There are customers who have basically their entire application ecosystem and architecture, everything is built upon Linux. In a startup ecosystem and a lot of other ecosystem, their app development and DevOps is completely Linux-based. They were only maintaining a Windows server for SQL Server, obviously, because SQL Server is the enterprise platform they want. And that basically means they had to maintain 2 different types of skill set just for system administration and continuous support. And these are the customers who are looking to basically say, you know what, SQL Server is available on Linux. Why? I'll just standardize on that. We are seeing a lot of customers basically doing a standardizing on Linux ecosystem because it makes sense for them. The other set of customers that we are starting to look at is, they have been using other databases, for maybe new application or their old application. As their applications grow, they wanted more scale, they wanted more power, and well, let's just say some of our competition just doesn't do as well as we do. So they were looking for this, but they didn't want to, basically get Windows ecosystem because it's just, as I said, it's an overhead for them. So these are the set of customers who are basically looking at either ditching the database platform or just using the new SQL Server on Linux for the new applications. So this is a common pattern that we have seen. So, and some of the common questions that we keep getting about this: is it the same as Windows? Answer is yes, it's the same binary. Obviously, there are certain differences in terms of install, the configuration, because we want to adhere to the Linux ecosystem, the Linux standards. But when it comes to the databases, your T-SQL skills and your database development skills, they just go right across no matter which OS that you choose. Then is the performance same or not? And I'll just show you a metric in a second, but some of our TPCE benchmarks are SQL Server on Linux. Today, #1 benchmarks are SQL Server on Linux. Do we see, and what we have noticed is, if you basically do a side-by-side comparison for SQL Server on Windows versus SQL Server on Linux, for some workload, one has maybe 2% benefit. For other workload, other platform has 2% benefit. Doesn't really make a difference. It's basically, you'll get the same industry standard and scale performance as you would get if you were to deploy a SQL Server on Windows. Then is the licensing the same? It is the same license. As long as you have asset benefit, you can actually just install SQL on Linux and transfer your license over there. The other question we get is, do I need to know Linux? And the answer is a little tricky, but yes, because we want to conform to the Linux ecosystem. You need to understand a little bit about the installation. You need to know a little bit about the configuration pieces of it. But if you are a DBA only and if you are just focused on your T-SQL workload, or if you are a T-SQL developer, no. That remains exactly identical. Then, is SQL Server different in container? No, Once again, it's the same binary, just packaged differently. And I need a multi-instance environment. I want to run a DevOps and multi-instance environment. What do? Because we only allow one single installation on the VM itself or the Linux host itself. Use containers. I mean, very, very valid approach. And not only that, as we have been working with our partners such as Red Hat, we have actually made positive contribution to the Linux ecosystem as well. For example, we worked very, very closely with our partners in Red Hat and some of the other Linux developers, and we improved the I/O subsystem performance for basically something called FUA-bit usage. And there is a blog from Bob Dorr. Bob Dorr is one of our lead developers, and you should just read it. It will blow your mind away. So you should just you should see that as SQL Server has been coming to Linux ecosystem, it's also been a positive contributor to the ecosystem. It's bringing that forward as we move forward as well. And this, I know it's a little hard to read. I was actually trying to see if I could make it a little bigger. But if you see, this is sort of our list of benchmarks. And if you noticed in the Rohan's keynote, he talked about a new 30 terabyte world record benchmark, right? Did anybody hear that or remember that? Yeah, that new 30 terabyte world record benchmark is on RHEL 8. That's SQL Server running on RHEL 8. So that's where your performance is. I also wanted to showcase, we not only have some customers who just want to give their logo, but these are the customers, real life customers who are using SQL Server on, in this case, RHEL. XM is an energy company in Colombia, and they actually work in the Latin America region quite a bit. And for their speedy development, DevOps purposes, they actually are using SQL Server on RHEL 8 in production, and they are getting a benefit out of this. So, yeah.
Hi, is Linux supporting Active Directory integrated security as well?
Are you talking about Active Directory? Yes.
Yeah.
I'll show it to you.
All right.
Okay. So now let's, yeah, go ahead.
Traditional Windows failover clustering supported?
It is, with one minor limitation, and I'll talk about, actually, can we hold the question for a little later part? And I'll try to answer all your questions. So let's talk briefly about SQL Server 2019 in general. What is it that trying to solve? And this is more or less what Rohan has been talking about, what Bob has been talking about. So I'll just briefly walk over this. And some of the problems that SQL Server 2019 solves today are the access to multiple data sources seamlessly, the availability across multiple platforms, be it Linux, be it Kubernetes, be it ARM. It also solves the problem of extensibility or extending the T-SQL language, because T-SQL language, while it's amazing language and it's one of the most popular language, it has its own limitation. It's because it's meant for databases and not for general programming. And we have been solving that by adding extensibility into SQL Server. Intelligent performance, and Connor was very clear about it. We want to have you a better performance, improved performance, without you lifting a finger for it. And we have been working very, very hard on intelligent performance as a feature. The layers of security and compliance, we have new feature called always encrypted with secure enclaves, which improves the performance. And of course, accelerated database recovery. This is something Bob showed it, and we love showing this because we have all been through a pain of long recovery and rollback situation, and this is one of the key improvements for SQL Server 2019. So what about Linux specifically? And I just want to briefly mention about Linux. So if you take a look at this chart, now this is basically comparing feature list between SQL Server on Windows and SQL Server on Linux. The black dots you see were the features which were already existed for SQL Server on Windows and SQL Server on Linux when it got released in SQL 2017. The blue dots are the new functionality that we have basically added for SQL Server 2017, rather SQL Server 2019. And we are actually improving on some of the scale part as well. For example, right now it mentions 12 terabyte memory support. We are working on 48 terabyte memory support. So you will be able to run SQL Server with 48 terabyte memory soon enough. We are working on that. So let's take a little more deep dive into that.
Yeah, actually, before you do, Tejas, I just wanted to make one point, which is that there were certain things on that chart, like BI and I think SSMS,
Right.
that are really more Windows client than they are Windows Server. And those things work fine with SQL on Linux, just as they do with SQL on Windows. There's no difference in the behavior of them. They just happen to be tools that run on Windows desktops.
That's a very excellent point. So BI, some of the BI tools and SSMS, those are Windows-only tools, but they work just as fine with SQL Server on Linux, as you will see. So let's dig a little more into the SQL 2019, the new capabilities. What did we do? So with SQL Server 2019, we have brought replication, CDC, and we are working on availability for Kubernetes. This is one of those features that if you attended Slava's Unplugged, he talked about that we are working on that. We have also brought machine learning and the language extensibility to SQL Server 2019 on Linux. We brought Polybase to SQL Server 2019 on Linux. We have brought distributed transaction support for SQL Server 2019 on Linux. To go along with that, as we came to the new architectures, we have seen new hardware enhancements as well. And one of the trend is about persistent memory. And yes, SQL Server on Linux also supports persistent memory in a couple of different ways. We brought third-party Active Directory provider support as well. We actually brought it back to SQL Server 2017 too, if you believe it. And we have some container-related improvements as well. But you have to remember, everything I just talked about, replication, distributed transaction, they also apply to containers. It's just another SQL Server in a different package. That's it. So, and along with that, we are bringing support for more current Linux platforms. In fact, SQL Server 2019 supports RHEL 8 already. I'm just waiting for the new package, RHEL 8 native package to be dropped so I can publish it. But SQL Server 2019 brings support for the more current Linux platforms, and we will work on bringing that to SQL 2017 as well. So let's dig a little more into this. What do we mean by this? Now this is not a session on replication. This is not replication is a feature that's been in system for close to over 2 decades now, right? And it's one of the features. In my personal opinion, it hasn't deserved the attention it should. But many people we have seen, actually many customers use it today productively in their environment. This was not available for SQL Server 2017 because it required certain additional packages that we weren't ready for. And with SQL Server 2019, we bring replication to SQL Server on Linux. And as we enable the replication packages and the components, CDC also becomes available as well. And I know a lot of customers who use basically CDC and some of the other third-party tools like Golden Gate or something with CDC for their SSI or basically ETL kind of needs. It is available with SQL Server on Linux now. Let's just take a quick look at that. Transactional and snapshot. The merged application, we are still considering it. I mean, we need to test it, but we don't know if many customers use it or if many customers should. That's a different story. Differences of opinion there. So let's see. Do you want to use it? And it works, but do you want to use it? So first of all, I've got a bunch of SQL servers over here. Come on. By the way, this is a VM in Azure, so and I'm going via public network, so sorry about that. But I've got a bunch of SQL servers over here, and I'll just expand them. And can you tell me the difference between which one's Linux and which one's Windows? The icon. That's the difference. That's the only real difference now. Now, this one is a SQL Server on Windows, and this one is SQL Server on Linux. In fact, SQL Server 2019 on RHEL 8. And it's got the same databases. I think I should be able to show that. AdventureWorks, if you want to see the tables, it's the same tables you'll be able to see. It's basically the same thing. You got a SQL Server 2019 running on Linux, working the same as SQL Server 2019 running on Windows system. Now let's just focus on the replication part of it. So if you were connected to a SQL Server 2017 on Linux, you would not see this particular node over there. Now this is available. I actually just configured the distributor already, but if you see the distributor, it's you all configured the application once in your life, right? It just works. It's the same thing, the same tools which work both ways. I can go here and say new publication and simply walk through the wizard. Let's say AdventureWorks, transactional replication. Okay. Yeah. It's been doing that. I need to upgrade my SSMS, but I actually configured this on my machine here a bit ago. And I got a publication and a subscription, and it's got the same tools working with the SQL Server on Linux. Yeah.
Oracle subscribers supported?
No, Oracle subscribers are not supported, and they are actually frankly deprecated for SQL Server on Windows as well. Yeah. Do you have Oracle? Yeah. Let's talk afterwards. I'll put you in touch with Kevin Farley. Yeah. So you got the same publication, same subscription, same utilities, SSMS working with this. Your monitoring works exactly the same. You are used to monitoring it with replication monitor, and because this is not a replication demo, this is more about this capability working on SQL Server on Linux. I'm just walking through this, but basically, as you can see, this is replication, a transactional replication working on SQL Server on Linux, just as it would on Windows. And let's just I think should. Well, hopefully it will just show up here in a minute or so. But now you can see this is working, right? Transactional replication working on SQL Server on Linux. By the way, there was a question about Active Directory authentication, right? In this particular case, in this example, I'm connected to the server using SA password. In this example, I'm connected to the server using Active Directory account. It just works. It is exactly the same. The configuration for Active Directory is different, but the functionality from the SQL Server perspective is identical. Okay? And let me just do a quick demo of CDC as well while that is being initialized. So, okay. So I got, what I'll do is I'll just create a sample database and enable CDC on that. Enter some data in that. Okay. See, I've created it, and then let's just see if CDC has worked. And as you can see all your CDC metadata over here. It's just there. Just the way if you were to enable CDC in SQL Server on Windows, it just works just the same way. And I can insert and update some data, and now I can get the same functionality that I used to get for SQL Server on Windows, all the changes, the changed captures. So as I was showing this, basically you got transactional replication, snapshot replication, as well as you got the CDC capability working for SQL Server on Linux as you would have on SQL Server on Windows. And it's identical. So if you had, if you were thinking about moving to SQL Server on Linux and you were blocked because the certain functionality wasn't available, it just works. Question?
Since it's working on Linux, does this imply that CDC, change capture, replication are going to get a bit of love from Microsoft and maybe enhance some of the functionality in these areas, limitations?
Talk to me after the session. Yeah.
Is there a replication support on availability groups in Linux?
Yes.
Is remote distributor required still?
Not required. In this case, for example, the distributor was the local server itself.
But it wasn't always on.
Yeah, always on. It requires some specific additional configuration, but that's more always on specific over this. There was a question there.
Yeah. Do we have to use a container in order to use the SQL Server on Linux?
No, SQL Server on Linux works on host itself or containers. It's your choice. Actually, can you hold the question a little later? I think we have a lot to talk about. Yeah.
I just was wondering about the state of AD authentication inside Linux containers.
It is coming. It is coming.
But it's not right now.
It's not available as of today, but we actually know how to make it work. We just need to productize it because we don't want to make you walk through 20 steps to get there. That's all.
Coming.
Yeah, it's coming soon. So that was SQL Server on Linux having replication and CDC functionality. Another functionality that we talked with customers and they wanted this was distributed transactions. So many of our customers have actually been using distributed transactions in their systems with multiple databases, and because distributed transactions weren't available in Linux, because obviously MSDTC service doesn't exist over there. So we worked to bring MSDTC service into SQL Server on Linux, and now it works just the same way you would. Configurations are slightly different, but it just works. So for example, your MSDTC client will go to port 135, which is the standard MSDTC port, find out on which port SQL Server MSDTC service is listening to, and basically connect to SQL Server with on that MSDTC port, and just do the distributed transactions. And let me just show you with a quick demo. Once again, okay. Let's see. Okay, so in this case, once again, I'm not trying to show the distributed transaction as a functionality. I'm just trying to show the distributed transactions exist. I have a bunch of link servers that I created on the server, and I just want to run this query to go to a link server, which is, in this case, it's a Windows server. Actually, let me connect to another server. Nope, I was on the right server. My mistake. So in this case, I have a link server to a Windows server. I have a link server to a SQL Server 2019 on RHEL 7.6. I've got a link server to another SQL Server 2019 on rel 8, and I can, okay. Yeah. Tends to do that to me once in a while. But now I can begin a distributed transaction across a Windows system and other Linux systems and just do a distributed transactions. It just works. Now, more importantly, what I, the other question I get is, but what about containers? Containers actually present a very interesting challenge there. It you can get into really interesting configurations. So I'm actually right now in middle of publishing an article on how to configure MSDTC on containers, but it works. You can get in, you can actually create some very, very interesting scenarios where you have 2 containers on the same system, 2 containers on different system, or application on the host and containers in different system. And you can actually create, run distributed transaction across all these different kinds of variation. Your distributed transactions will just work. And soon enough, you'll have proper documentation on how to do that for containers as well. So, and another point that I wanted to make was both, so distributed transaction or MSDTC functionality is already available with SQL Server 2017. We actually backported it for you. And the replication functionality is also coming to SQL Server 2017. So replication or CDC, if you are used to that, and if you want to deploy SQL 2017, it's going to be available as well. Question?
Question, when you created the MSDTC service, you simplify the RPC endpoint part. Because one of the hardest parts about MSDTC support is you have to open endless ports in a firewall. And if you make that simple, can you please backport that to Windows?
OK, we can talk about it. Yeah, that's a fair request. We can talk about it. Yeah. So next, now, how many of you have seen Polybase demo so far? I mean, in the last 1.5 days, everybody, right? One of the things that you might have noticed is that everybody wants to show the Polybase demo with big data clusters, right? Everybody wants to showcase how you can use Polybase in big data cluster to connect to HDFS and connect to use Spark to get the data and everything, right? Well, Polybase as a functionality is not native to or limited to big data clusters. It is available on standard SQL Server 2019, and we have also brought it to SQL Server on Linux. So you can create, you can use Polybase, create external tables to other data sources, and use the Polybase functionality. And why is Polybase as a functionality very, very important? So, and this is, I actually like to tell a story about this. And in a previous job when I was working, and that was like, I guess 16, 17 years ago, they had a system where they had a SQL Server running their core basically application. They had a small little MySQL application which was doing some transport management for employee or something. They had another small database somewhere, and for I think HR or payment expenses or something like that. So they had all these disparate data sources based on their requirements, but all of them related to the employees. So one of the days, actually, a senior executive asked this question. So I've got employees who are doing this business. At the same time, they need certain things, like they need payments, they need whatever else. Also, they are using some of our facilities. How do I know who is using what? How do I correlate all of this data? And the answer was, yeah, well, you basically pull the data from one data source to another data source, and you merge it somewhere, create a data warehouse, ETL. I mean, that has been the standard experience, right? But Polybase as a functionality basically breaks that barrier for you. It basically gives you a native way of accessing disparate data sources. And not only, so another one I keep getting questions on was linked servers. They have existed for a while, right? So why Polybase? And linked servers are meant to access other data sources, right? The idea is the linked servers have well, they are visible to the actual developers. They require additional infrastructure, so developers have to know how the data is, where the data is, and how to get to the data. Developers shouldn't have to know about that. And that's why we created Polybase as a feature which allows you all these different data sources, and not only relational data sources. Linked servers are limited to relational data sources, but Polybase is not. It can access NoSQL data sources, it can access HDFS, big data sources as well, and it can allow the access seamlessly so that the developers don't need to know where the data is coming from, just how to use the data. So whenever I talk to Travis, and Travis basically likes to explain this as a Polybase is a semantic layer which separates what you want to do with the data from how you want to do it. Basically it changes, it separates these two layers and allows developers to be developers, and basically takes away some of the responsibility of managing access for the data. So let's just take a quick look at how this works for SQL Server on Linux as well. So once again, let me see. Okay. So I'm connected to a SQL Server 2019 on a RHEL 8 machine, and let me see if. As you can see, it's a SQL Server 2019 bits on RHEL 8 machine. And what I did was, let's just do this. Let's just walk through a scenario where I want to basically access some other data source from here, in this data source. And the same tool or same wizard that you are used to for the other demos, it's available here as well. So I can do a Oracle data source, for example, and say I want to access, I already defined my data source, so let me see if I remember the database name. I think that's the right database name. And let's see. And I've got the same access to other data sources. I can simply walk through this and okay, let's say I want to create an external data source on this particular view in Oracle. I can, and if I say create, it will do it for me. I think have already done it. So let me just show some of this. And remember, this is not BDC. This is SQL Server 2019 running on RHEL 8. It's a single SQL server. And I've got this bunch of tables over here. For example, this was the table I was just walking through. This is the data source is pointing to Oracle data source, and I'm querying Oracle data source from SQL Server. It just works. What about another SQL server? So I've got another external table created for another SQL server. Well, that also just works. It's an external table, and from the developer perspective, it's just another table. I've got the same information, same schema information, and developer or T-SQL developer doesn't need to know how to get to the data. That's already been taken care of. They just access the data. What about another data source? Let's say, this one is I think Cosmos DB. Well, no, this one is Cosmos DB. So I'm just accessing a Cosmos DB data, Oracle data, and T-SQL, a remote T-SQL SQL Server data sitting from SQL Server 2019 on RHEL 8 machine. So now what this allows you to do is, for example, okay, let me just close out a few windows. Which server was it? Okay, rel 8.1. Okay, so now as a T-SQL developer, you can tell people, you know what? Go nuts. Create something that's productive. Don't worry about where the data is coming from. And you can create intelligence across multiple data sets. So for example, in this case, when I'm running this query, it's actually accessing Cosmos DB data, Oracle data, remote transaction, remote SQL Server data, and joining it with a local, local table data, and it's giving me a result. And your SQL developer doesn't know. Everything just works. And this is happening happening in SQL Server 2019 on Linux. You don't need a BDC for that, by the way. So.
If you start joining like large tables, performance may not be as
It's,
good as it would be if there was all of
it's always a case of you knowing what you need and scaling for that, right?
It's a good point. It's a good point because one of the things that BDC does do is it caches everything in SQL. And unstructured data gets cached in Hadoop. So if you think of that, essentially it's creating those caches so that those costs of going over the network
Right.
you don't experience all the time.
It allows you, if it's a BDC, you can create data pools for local caching. Obviously, your caches are only as valid as you needed them to be, right? So those are the trade-offs, and those are always the trade-offs that you can make. But those are design decisions. The functionality is there. You just need to make design choices to fulfill your basic needs. Then next one is the extensibility. We have had a lot of customers exploring how to basically do machine learning within databases. And I can't name the name, but there is a huge semiconductor company who wanted to basically do tweet analysis, and they wanted to understand that another phone company is basically putting out orders to them for X number of chips, but how many would they really need to ship? They didn't want to do overproduction, even if there is a commitment. So they were doing tweet analysis just to figure out how many would I actually need to ship. And this is, by the way, a real life scenario. And these guys built a system for within SQL Server to do tweet analysis using machine learning algorithms to do the prediction as to how many what is the order, how many would I need to ship. Would I need to underproduce or would I need to overproduce? Maybe the phone is going to be popular, and I probably should be ready for additional chips so that the other company gets better experience, and they'll probably renew the contract. So this is an example of a company actually doing manufacturing based on machine learning analysis using the tweet information. And this is what they are doing in SQL Server. They started with SQL Server 2017. And they wanted to actually go to SQL Server on Linux because the rest of the ecosystem is on Linux, but they couldn't because extensibility as a feature did not exist in SQL Server 2017 for Linux. No Java, no R Python integration, it just didn't exist. So with with this requirement and customers actually requiring this, we brought R and Python integration for SQL Server 2019 on Linux. While we were doing all of this, we actually talked with a bunch of customers, and they actually had a very valid point. Python is not just a machine learning language. It's a programming language. It's a general purpose programming language. You can do a lot with that. But Java is better. Java is better at doing a lot of things and easier to do in terms of programming, and in many cases more performant as well. So they wanted to see if we can do Java integration as well. So we basically did Java integration for SQL Server in 2019. And now, because we are building everything at the same time, it's the same binary, and we got the same architecture, right? SQL Server, this entire language extensibility, including Java integration, along with R integration and Python integration, is available on SQL Server on Linux. And obviously, there are other benefits, like you can do all of this, which is secure and isolated, and at the same time resource governed as well. So you want to do machine learning, but at the same time you don't want to overcommit the resources. You don't want a performance hit on that. You can actually do this with resource governor as well, and it works same way for Windows and Linux. Implementation is different, but it works exactly the same way. So you've got the resource governance for all of that component as well. So let me just do a quick demo on that. Okay, I think I'm at the right server. No. By the way, bear with me, my fingers are frozen. Yeah. So let me see if I'm connected to the right server. So in this case, I'm connected to a SQL Server 2019 on a RHEL 7.6 machine. Just wanted to switch around the demos just to see showcase that everything works everywhere. And what I have done is, in this case, I've already created a database. And so I'll just walk you through the steps. So in this case, I'm creating a table with a bunch of random strings, a sample database and a sample table with a bunch of random strings. And then this is how extensibility works. Now, first what you do is create an external language. In this case, Java as a language. In this, you have to specify the path where the extensibility packages are. And this is one of those things that that's slightly different for Linux versus Windows, but it's a configuration time, so it's a one-time thing. And once you created the language, you can start creating the package. And you can actually store the packages directly in the database, or you can store the packages in the disk and load them at the runtime. If you load them at the runtime, you have to make sure all the permissions are properly given. It tends to be easier to keep them in the database itself, because then you don't have to move around those packages separately. But in this case, I created external library or packages inside SQL Server using the jar files, and then I created a simple simple store procedure. What it does is essentially it calls a function within the within this particular package, and it's a regular expression code. It's one of our famous example. I think Bob might have shown this before somewhere as well. And this is something we have documented in our books online, so you can actually just walk through it. And one of the things, for example, T-SQL is not good at is regular expression work. If I wanted to write queries for a regular expression, by the way, it's not impossible to do using T-SQL. It just isn't performant, and we know that. The general programming languages tend to be better for stuff like regular expression. So what I've done is I've created this particular store procedure to call a regular expression in a passing package, and then let me see if I have everything ready there. So now, this is the sample that was given in the books online, which basically says I want to select all the strings from a table which has word Java, where J could be capital or small. Now this is actually very easy to do in T-SQL. So I didn't think that was the best example for showing the power of regular expression. But what if I wanted to find all the strings which have repeated numbers, or if I wanted to find all the strings which have repeated characters, but repeated characters or numbers, but not not where the characters are not repeated in a sequential way. So for example, let me just show this. I've got a couple of strings in the table. In one case, in the first case, for example, I'm saying, find me in a row which have repeated numbers. That's it. 0 to 9 numbers in a repeated way. Give me just that string. And it gives me this. If I had to write T-SQL for this, it would take me probably a day, maybe more. Or another example is, just show me strings where any character, number or character is repeated, and I can get now 2 strings. In one case, I've got repeated R. In the other case, I have repeated 2 in a sequential way. So this is the kind of work which is very well suited to regular expression. It's not very well suited to T-SQL. And now you can call general purpose languages like Java or Python using from T-SQL itself to do some of this complicated work in a resource governed way, in a secure and isolated way, at the same time on Linux as well. I'm running this on SQL Server 2019 on RHEL 7.6.
The other thing I'd point out is you can use other frameworks besides the ones that Microsoft is providing. For example, PyTorch, TensorFlow, and those things can be hardware accelerated too on the system. So you could have an NVIDIA board that was accelerating that if you're doing actual AI on your data and want to then take action on it. You can actually do that from that level, which is really powerful, as you can imagine.
Exactly. So what we are showing is in a simple example, because let's face it. We are SQL Server developers, program managers, but we know you are capable of doing so much more using the tools that we have given you. You are so much capable of running machine learning algorithms or general purpose programming for complex programming needs, and with the tools that we have given it to you. Next, I'm just happy to announce that now with SQL Server, we have actually worked with our colleagues at Red Hat to bring high availability, essentially availability groups for SQL Server in Azure as well. Until now, you could not build an availability group or technically FCI in Azure with Red Hat VMs. Now you can. Luis, do you want to talk about it?
Yeah. So one of the things is some of the other Linuxes did offer Azure VM support for availability groups, but they did it with something called the soft-dog fencing mechanism, which is a real problem because soft-dog is essentially implementing a hardware watchdog virtualized. And so anything that goes wrong with the underlying hypervisor is going to not be detected. And you can get into situations where the hypervisor itself is hung, and that can create all kinds of mayhem and data corruption. So we weren't willing to actually support HA in Azure until we had a way to actually force off the VM. And so Microsoft worked on that and provided us with a new means to actually guarantee that when we send a signal to a VM, it is turned off. Basically, it's a kill switch for a VM, which didn't really exist in Azure until we asked for it. What really happens when you turn off a VM in Azure is maybe it goes off, and eventually it goes off, but it doesn't go off right away. And of course, for a high availability situation, you need to be able to shoot it in the head. And so they've added that. There's an excellent blog on the issue of soft-dog timers. I strongly don't recommend you use them in Azure. And there is there was a full certification process that actually took a while to figure out how to configure everything. Routing, I think, was the biggest question. And the load balancing, because of course you've got the Azure load balancer, and then you've got SQL itself with AGs doing load balancing, and reconciling those two is always interesting. So I think that's about everything I had to say on that.
Yeah, so just imagine, Microsoft and Red Hat working collaboratively to bring new capabilities to you. Who would have thought maybe 5 years ago?
Another really good point is that there is this SQL on RHEL Azure Operations Guide, which is super detailed. This is a full reference document, a full reference architecture for Azure, and gives you a lot more details than we can give you in any kind of session.
Right.
And in fact, I think at some point we're going to do a webinar where we go through that entire operations guide. So we're really keep an eye out for that.
So basically, this operations guide essentially walks you through how to deploy in a VM and install SQL Server and configure SQL Server to nearly production-ready status. Both our teams have worked together. We have got a couple of team members here who also helped out, and we have brought this to you so that you can actually get to production in a as quick a fashion as possible using the recommended approach. So.
Yeah.
And we are going to work upon the documentation for high availability as well. It's probably going to come out in next week or two. So
Yeah, right now, I think the documentation covers using AGs for read scaling, but not for availability.
Right.
So that'll get added in here in the next week, I think.
Right.
Or so.
So apart from this, I just wanted to quickly mention that there are a few other things that are coming to SQL Server on Linux, and one of those things, I know intelligent QP and accelerated database recovery have nothing to do with Linux, but that was the whole point. These are a couple of key features that we are introducing in SQL Server 2019. And because of the way we build stuff and the way we ship everything to you, the same features are being developed are coming to Windows and the Linux at the same time. Hopefully, by next year, let me put it this way. Hopefully next year you won't have this session talking about SQL on Linux, because everything that comes to SQL Server comes to SQL Server no matter where it is. So we also have persistent memory support coming for enabling new hardware architectures using persistent memory. It could be hybrid buffer pool scenarios, or we have a specific enlightened IO method. Actually, we are trying to change the word there, but basically, we allow you to put your files into PMEM disks, and internally, as we recognize that they are PMEM disks, instead of going through the entire IO stack, we'll just do the mem copy. It's blazing fast.
Bring that to Windows?
So the hybrid buffer pool is already coming to Windows, and enlightened IO we are working on that on the Windows side. It's work in progress.
Yeah, direct. It is not a cut at Windows Server at all. It's taken us years to get a DAX, or direct access, working with the XFS file system, and officially for general purpose applications, it is still listed as Tech Preview in RHEL 8, but we have an exception because we've tested SQL Server so much. So SQL Server and another application, SAP, I probably shouldn't mention them, but those two are the two that we've actually done that level of testing with. And so they both support the DAX subsystem for app level persistent memory.
Yeah.
Are you guys going to offer RHEL 8 or 7 in containers instead of Ubuntu?
Yes.
It is coming.
It is in preview now, and you can go and play with the containers now, but the final container is literally coming out in another week or two. So
exactly.
You might just want to hold off and get the actual production container.
Another thing, I'm not sure if everybody realizes, is that if you actually build a container, if you take the base image from their ecosystem and actually build your own container using SQL Server, it is supported.
Yeah.
We will support it. So if you want to build your own RHEL container today and put it in production, we will support it.
Yeah.
It is supported. It's just not very well understood or explained, the unfortunate part of it, but it is supported.
Yeah. CentOS is not supported.
CentOS is not supported.
Yeah, not by Microsoft. And Red Hat, obviously, we support the CentOS ecosystem, but we don't actually offer support for CentOS.
Yeah, so
there's also, you should be aware that the container itself isn't actually built with RHEL. It's built with something called UBI, or the Universal Base Image, which is the same binaries as RHEL, So when you see UBI 8, it's the same as RHEL 8. It's the free version. You don't have to have any kind of licenses or anything for it. And when we build all of our containers, we build them with UBI. Our ISVs build them with UBI, and you can run them anywhere. So if you want to just do test runs on a CentOS environment, that's fine, or on Red Hat developer workstations. But we support it on Red Hat Enterprise Linux, and we support it on OpenShift. So for production enterprise environments.
Windows-based containers are in private preview. If you want to test them, please feel free to reach out to me. I'll put you in touch with the right people. Yeah.
Now, ODBC from Linux to SQL, do you have, that's always been tough. Client, how do you connect to SQL?
I mean,
It's only ODBC on Linux.
It's Unix ODBC. It's a Windows, it's a Microsoft thing.
Right.
And there's actually a repository for it that'll automatically yum update to everything. All of the Red Hat tools all integrate in with it. Yeah.
Yeah, they will work. So
Yeah.
let's just move on. Lois, you want to take this one?
Sure. I think you've got one more question.
Question, with ADR,
Yeah.
can you leverage PMM through within Nightingale?
Yeah. Yeah, it works.
So just like SQL Server hasn't been standing still, Red Hat Enterprise Linux hasn't been standing still. And in fact, the two companies worked really closely on our mutual releases. So there are features in SQL 2019 and features in RHEL 8 that leverage each other. I know that Tejas already mentioned the FUA, or Force Unit Access, changes that went into XFS. Those were pretty big changes, which is why they're not in RHEL 7. We don't do major changes to our releases until another major release number, because we don't want to destabilize the software in a minor release. We also created a TuneD profile. This is actually available in RHEL 7, but it's advanced a lot in RHEL 8, which is a way to tune the operating system for SQL Server. And you can do that with a single command, or even through our web console. You don't need to be typing in the 30 commands that you see in the documentation to go and configure that. It's all done for you. And what's really neat about that is that file actually gets updated every time we have a new update with the latest things that we figured out to do. And you can actually rerun the TuneD, reapply it, and periodically, and you'll get performance improvements. We also did a lot of work around direct access, or DAC support, and we talked about persistent memory already quite a bit. In some cases, we're seeing 100% performance improvement with DACs. In other cases, it's more like 50. I should say also that the FUA changes particularly in Azure, which makes extensive use of battery-backed disk caches, that those changes improve performance by, again, a factor of 2 in some cases. So that's a pretty big performance win. Another thing that we did is we really went through and improved manageability, thinking about the SQL DBA who's coming to Linux for the first time. And we did that in 2 ways. One way is we added a service, which we've sold as a separate product for years, called Red Hat Insights. Actually, not going to forward yet. Insights is essentially an online service. We upload the changes from our logs to that service every night, and we clean the data, scrub the data before it goes up, run analytics on it, and based on all of our support data for all of our customers, we go through and we determine if there are problems. We can recommend security patches, we can recommend configuration changes, and we can actually give you Ansible scripts to go back to your system to fix the problems. And you can deploy those with our Red Hat Smart Management service, which is still an add-on, or you can just deploy them manually. What's cool about Smart Management is that it gives you Red Hat Satellite, which is our software management system. It also gives you a way to better manage those vulnerabilities and check for compliance. And it gives you a way to compare systems side by side. So if you're using staging servers and want to make sure that those are matching the deployment servers, that's just generally a good idea. It can do that automatically for you and give you reports nightly on that using the same underlying technology. The other thing that we did is we enhanced our management console. I mentioned the web console already, which greatly simplifies administrative tasks. There's a webinar that you can go see on the Red Hat site that actually demos creating a storage volume and expanding it by adding in an extra drive with just a couple clicks. And storage is one of the areas that's much more complicated to newbies moving from Windows to Linux. So making that easy was a really big area for us. You can also configure networking. You can add a server to AD. You can do all of these things through the web console, although there are still steps to add SQL Server into AD, which for those you have to go onto Windows and generate the file. So increased security. Yeah, so we actually introduced system-wide cryptographical policies, and this is something that SQL Server for Relate will support. So say your company mandate is that you want to make sure you have 4K certificates. You do not want to allow a 1024 byte certificate. You don't want to allow a 2K certificate. It's got to be 4K. That's your company policy. Well, you can actually set that as a system-wide policy on the RHEL system, and SQL will enforce that policy. So that would then force you to, I think the default SQL certificates are 2K, and that would require you to go back and make new certificates, which you want to do because otherwise you're out of compliance with your corporate policy. So all of those things become enforced system-wide, and kind of those rules can be set across the system, and SQL will honor that. We also updated all of our security APIs and protocols, and we added session recording, which you can use to monitor as an audit of any command line interactions that have gone on in the system. I mentioned Red Hat Insights. Red Hat Insights does a number of different things. It can help you identify risks in terms of security. It can find performance problems, and it is tuned specifically and understands SQL Server. So a lot of the things that are in the SQL for Linux manuals and documentation, we've actually gone and added those checks based on those recommendations into SQL. So if, for example, you weren't running the TuneD profile, you were running a high throughput profile instead of the one that's optimized for SQL, we would catch that. If you had permissions wrong on certain directories, we check that for your data or your log. And so all of these things are reported back to you, plus all just the general things about an operating system using the Insights tools.
Okay. So, and once again, I'll just briefly mention some container-related improvements. Now, what I won't mention here are the feature improvements, because remember, once again, SQL Server on Windows is the same as SQL Server on Linux, is the same as SQL Server in containers. Just the packaging and wrapping is different. You might have certain configuration differences, but the SQL Server is same. So the functionality remains same. What additional things what we did for you in terms of containers is we have basically created a completely managed secure repository in Azure, what we call Microsoft Container Registry, and all our container images will be served from there. When we do link to Red Hat sites and some of our partners, but they will be served from Microsoft Container Registry, so you will always get the right containers. And of course, you can obviously build your own containers, which are supported as well. But if you use a container, you will you can rest assured that it will come from a secure repo. We have additional container images which are in progress. They will be coming out to you shortly. SQL Server 2019 containers run as non-root, which is one of the primary requirements for a secure enterprise environment such as OpenShift. And it will now run as non-root. So now you will be able to run SQL Server containers in OpenShift. We are working on that piece of the support, final pieces, and it is coming to you. Okay, everything is coming to you. So you'll be able to run your containers in Kubernetes and OpenShift infrastructure in an enterprise manner in a completely safe and secure environment, and running as non-root from the security perspective. And you want to talk quickly about OpenShift and SQL Server?
Yeah, so I think there were a few questions, but let me just cover OpenShift really quickly because I think there is a perception that Kubernetes is OpenShift and OpenShift is Kubernetes. And they really are not the same thing. OpenShift uses Kubernetes. It is a container platform. It has a service mesh based on a technology called Istio. But in some ways, OpenShift is way more flexible than the traditional out-of-the-box Kubernetes configuration. Kubernetes originally was developed running in virtual machines, and OpenShift is very much designed to run in virtual machines, but also on bare metal and also in clouds. So there's a lot more flexibility there, which can trip people up as they're going to do installation. There also is a lot more security. And we enforce a lot more rules in OpenShift, and the OpenShift community enforces a lot more rules than you typically would see in a Docker plus Kubernetes environment. You'll notice that Tejas has been very kindly not mentioning Docker except at the very beginning. The reason for that is that OpenShift and Red Hat, we actually don't ship Docker anymore. We ship Builda, and we ship Podman, and we ship Scopio. And those three are our replacements for Docker. Now, Podman, the Podman command, is completely compatible with Docker. And all the command lines work the same. Everything is the same with it. But a key difference in our architecture is that there is no giant daemon bloat. You literally, when you kick off a container on RHEL, you are kicking off that container. There's no service that's already running. You can kick that container off as a user. You don't have to be root to run the container. You can run a full SQL Server environment and not be root. So it's much more secure. It's much more lightweight. It performs better, and it's easier to manage. And that's all built into OpenShift. And the last real key difference between OpenShift and other distributions of Kubernetes is there's a different operating system. Now, Red Hat Enterprise Linux has two versions. It has Red Hat Enterprise Linux, and it has Red Hat Enterprise Linux Core OS. What you need to know is that Red Hat Enterprise Linux Core OS is developed to be essentially, think of it as the equivalent of the hypervisor. It's what Kubernetes and containers run on top of. Those containers can be running various versions of RHEL, or they might be running UBI, as we mentioned earlier. But the underlying version is this Core OS layer. And the advantage of that is that the Core OS layer is constantly updating. Just like with a hypervisor, you want that to be as secure as you can possibly get it. And so with Core OS, we're upgrading and putting security patches in whenever they're needed, just automatically. And that stuff can be scheduled and timed, and it's all built in to be very seamless. It's not like running a Windows desktop upgrade. But it is important to understand that all of that is going on behind the covers to secure this environment, and that the whole structure of OpenShift is designed around being agile in the enterprise where security is paramount. So it's not the same, and that's part of where our difficulty has been around supporting it, because I think even Microsoft has been a learning model, learning about what the intention is of OpenShift. OpenShift is extremely successful. It's in just about every major enterprise in the world. We actually do in-house labs, what we call Red Hat Innovation Labs, where we'll build a project. I don't know if any of you have ever been in a Red Hat Innovation Lab. Nope, no hands. But we'll actually build a project and from the ground up with the customer and build that on OpenShift and teach them about Agile and DevOps and everything else as a process. And in the process, we're actually starting to bring SQL Server into that discussion. So we've had several customers where SQL Server has been a part of this architecture, including very large ones like the Defense Department. So super excited about that.
Perfect. Thanks, Liz. Yeah, go ahead. Actually, if you just wait for 1 minute, and we'll just do the Q&A. So these are some of the resources that you should probably reach out to, and this have information about not just SQL Server 2019, but Linux and containers and everything under the sun. These are including some of the Linux labs, so you can get hands-on how to just do a hands-on practice and see how easy it is. And if I wanted to take you anything out of this session, I just want you to take this back, that SQL Server is SQL Server. SQL Server on Windows is SQL Server on Linux, is SQL Server in containers. It is just SQL Server. You should focus upon the SQL Server and not the environment part. Leave it to your the sysadmins to figure out if it fits, which environment fits your environment the best. The second is Microsoft collaborates with partners, our Linux partners such as Red Hat, to bring you the best from the Linux ecosystem. As he said, we are also learning and we are working together to improve the ecosystem as well. So it's a give and take that we do very, very well. 5 years ago, nobody would have said that, but we work really well with our Linux partners. And third one is, hopefully next year there won't be another session on SQL Server on Linux because it is just SQL Server. And you guys let us know, what you want me to talk about. If it's about deployment, configuration, I'll be happy to do another session on that part. But now it's just SQL Server. And with that, I'm just going to open for Q&A. I think time is up. If we don't have a back-to-back session, I'm just going to stay here, or I'll just stand outside and we can have a discussion to your heart's content. I'm not going anywhere. Okay? I would really like to talk to you about this. Thank you. And by the way, if you guys fill up the session survey and let us know how we did and what you would like us to do better, that would be great. Thank you.